side there, that fraction, that 5 over x plus 1 times x minus 4, that we can actually break it down into its two components. Like it says over there on the right, that's going to be very useful if you needed to use the binomial expansion on it. And also when we get onto integration, it's going to be a lot easier to integrate the two terms on the right. As you know, when you integrate, you work your way along term by term. So if you can just get lots of simple little terms to integrate, that's a lot easier than trying to integrate what's on the left-hand side. So we do that by creating these partial fractions, and there are two ways to do this. Okay, firstly by substitution, or secondly by equating coefficients. If you've got the choice, I personally think substitution is easier and quicker, but there will be occasions when equating coefficients is the only way to go. So I think it's important when we kick off with this that you just make sure you can do it both ways, and then you can obviously then pick and choose question by question, you know, going for substitution if that's allowed. Okay, so let's just go and have a look at some examples. Just waiting for, there we go. So here's example 8. Okay, so we're going to split that 6x minus 2 over x minus 3, x plus 1. So you just start off, whichever way you're doing it, whether you're doing it by substitution or equating coefficients, the first couple of steps are the same. So you just set the scene. You say that's always equal to a over x minus 3 plus b over x plus 1. And then you want to get the common denominator. So the first term, you're multiplying top and bottom by x plus 1. And the second term with b in it, you're multiplying top and bottom by x minus 3. So that's similar to what we've been doing the last couple of lessons. So you will see that for at the top of the page for substitution and at the bottom of the page for when we're equating coefficients, so far they're the same process. We then go and get them onto, we then focus on the numerators, don't we? We're just focusing on the numerator, and you will see that the two bits that I've put in the red rectangle are the same starting point for both methods. Okay, so you just need to be confident you can get to that 6x minus 2 is always equal to a x plus 1 plus b x minus 3. Now, we'll do it by substitution first of all, which is the top half of the page. So we're just going to pick and choose values of x that suit us to first of all eliminate a, and then secondly to eliminate b. Now, because a is in fact, no, we're doing it the other way around looking at it. So b is multiplied by x minus 3. So if we go and choose to multiply both sides by 3, all right, we're just choosing 3. Perhaps I'll just highlight this bit. Bear with me. So in order for us, whoops, that's big highlights. Let's make that a bit smaller. Okay, so in order for us to eliminate that x minus 3 that I've just popped in orange there, we're going to choose to substitute in x equaling 3, and obviously therefore the b term disappears. We substitute 3 in, and that allows us to work out that a is 4. So by substituting in x equaling 3, we can work out that a was 4. We then start again. How are we going to go and eliminate a? How are we going to eliminate a? Well, a is multiplied by x plus 1. So let's go and choose to multiply it, substitute in x being minus 1. So that eliminates a, allowing us to work out that b is 2, and our work is done. Okay, now with method B, equating coefficients, let's pick it up again at the bit where it's in the rectangle, the 6x minus 2 bit. So we multiply out the brackets, okay, and we gather like terms. So we have the x terms at the beginning factorized and the non-x terms afterwards. All right, so the ax plus bx have been gathered together and factorized, and then the a minus 3b has been left at the end. Now we can just go and what's called equate coefficients here. I don't know if you've come across this before. We can go and see that on the left-hand side, the number of x's is 6. Just circling that now in red. Okay, so by definition, that a plus b has got the number in front of the x has got to equal 6. So that's given us our first equation, 6 equals a plus b. Then moving on to just the normal coefficient at the end, that minus 2 has got to be the same as a minus 3b, giving us equation 2. Two equations, two unknowns, a and b, that allows us to work out what a and b is. And I think you can see from that one, really the substitution was quite a bit quicker, I think. Right, I don't see the need really for more examples. What are we saying here? Yes, we're just saying here, obviously, if we've got 3 terms on the bottom, 3 components on the bottom, then you can just break it down into a plus b plus c. All right, so it's just a bit more of the same. So they've just an example there. Again, I'm not going to spend the time going over example 9, but because we've got the 3 terms, 3 components on the left, we've just split it up into 3 terms on the right, a over the first term, b over the x minus 1, and c over the 2x plus 1. And then it's just a bit more work, isn't it? When you're trying to work out a, b and c, you just eliminate 3 different x's to eliminate them in turn. Yeah, that's it. Right, so I would like us to work our way through exercise 1D, please. Okay, this is an important skill. I want us to get this practiced. I think, how big an exercise is it? It's quite a big one. Yeah, so let's just go and be a bit selective earlier on. I think for question number 1, let's just go and do the odds. So do A, C, and E. And G. And then from then onwards, we'll do them all. I think this is going to take more than one lesson. Now, tomorrow is not a proper maths lesson, is it? So, well, I'll stop the recording now, because this isn't relevant to the recording. So I'm just going to stop the recording, and then I just want to have a quick discussion about tomorrow.